share this out. That's the tradition. You know the drill. Am I going live? This is going to blast in my face, isn't it? Oh my god. Mute. Reload. Apparently I'm live. Beautiful. Okay, go to the Twitters. Twitter.com. Have I signed into Twitter? I don't think I have. I might bring this over here. One password. Autofill. No, do not save my password. What's going on, my friends? Oh, has Chrome got a bug? Going live on Twitch. Running TensorFlow. Running at, let's mention TensorFlow. Right, TensorFlow can give some clout. Running TensorFlow experiments and making slides for upcoming course materials. Come and say hi. Beautiful. That's all we need to do. And then I'll do one in the Discord chat as well. You know the drill. If you're joining in, you have to tell me if you can hear me. I could probably just check this myself, right? Making materials for who said I got no chill? Someone in here. $10-hour video. All right. So what we need to do today, let me get my little stream session up. What is the date? Have we not done a stream since the 11th? That is sad. Okay. So stream today is what? The 18th of March. Yes, we've done it. We've added all the text, clean model loading code. And so today is, yes, we need to start making some slides. So you're getting an insight in here into what's required for making a course. Yuchi, what's going on, my friend? You getting ready for work? Have a great day at work. The stream will be on the archive channel later tonight. But thank you very much for stopping by to say hi. Let's go in here. We need to create slides for 07. Make a little playground with TensorFlow code and other shiz to practice writing code. Okay, so here's what we're doing. I've got a little keynote here. This is Milestone Project 1. Food Vision Big. This is how I make slides. So I've got a few slides that I've used throughout the course. So what I'm going to do is I'm just going to start adjusting them for Milestone Project 1. There's some beautiful slides here. And if there's anything I've learned with making slides, it's you can always make them more visual. So one of my mottos is never use text on a slide. So even for this is pretty text heavy. Never use text on a slide where a picture will do. So this is what we're doing today. We're making slides for this, create slides for 07, and we need to make sure Notebook 07 is ready for recording slide making because we're getting very close to recording. I actually took a few days off, like stream and making course materials because I had to get if you haven't seen the 10-hour videos, they're on my YouTube, but I had to get them ready. And so to get them ready actually took me a few days. So I wanted to make sure they're good quality, you know? I have this thing where it's like I have to do just stick to one task and get it finished and then get it done. So this is what we're doing. I haven't even signed into GitHub. I deleted all my Chrome history and this is what happens. We've got this notebook and you can see if you want to try out the course, check out, there's 14 hours of the course now on YouTube. I'm very proud of that. So part 1 and 2, this is probably the biggest project I've ever worked on. So now we're up to here. We're making materials for this. Next, in the next few streams, so over the next 2 days, I'm going to finish up this section here. And then the next streams, probably next week, will be 08 and 09. And then after that, we'll do the time series stuff. Ashik, what's going on, my brother? Good to see you here. I'm going to, how about we, yes, this is what I was doing, TensorFlow Playground. So this is what we're doing, making slides. Create slides for 07, you can see that. Hopefully you can. It'll be close enough. Yeah, you can see that. Keep it simple. So I want to make a little template here of model with mixed precision without mixed precision. So get data. We'll have a small data set here. Let's use from TensorFlow. Where's TensorFlow datasets? TensorFlow datasets. Let's write some code and then we'll make some slides. I feel like writing some code. TensorFlow datasets. How do I use this again? Import TensorFlow datasets. TensorFlow datasets as TFDS. Actually, I'm going to put my imports in a single cell. First of all, we need a GPU. Actually, no. We'll get that in a second. No, we'll get that now. Because otherwise, we'll have to... And we'll get TensorFlow. Import. What GPU do we have? NVIDIA SMIL. Do we have it? Oh, we have a P100. Mixed precision won't work. See, this is why we need to get a GPU first because we need to make sure we have a T4. Get data. So I think it's train data, test data. I want to get CFAR 10. List of data sets. Just 10 classes, that'll be enough. Image classification, CFAR 10. Here we go. CFAR 10. Test and train, wonderful. And then I also want ds info equals tfds.load. What GPU do we have? Yuchi, have a great day, my friend. And so stoked that you love Ashik's blogs. Is working on a mini project with what you learned from the course. Yes. Beast. Let's get this stuff up. So this is Ashik's project, learning TensorFlow. I'm going to star this as well. I need to sign into GitHub. Autofill. Sign in. I need to do the auth code. Should probably do that off stream, right? Auth code, make this really tiny. There we go. Okay, this is my boy Ashik's learning TensorFlow. The banger new course, yes. And hands-on machine learning, phenomenal book. And you have a project, flower recognition with TensorFlow. Lovely. Love this from you, Ashik. Flower recognition. View random image, great function. Randomness is so good for exploring data sets. Image data generator, yes, well done. You turned it into a function. It's very smart. Image data generator, this code is, the window is not big enough. Yes, convolutional neural network. Look at that. Boom. Ashik, this is amazing. Look at this, full scale project. Load the data. You've done that. Turn it into tensors, done that. Create a, this is turning it into tensors here. Building a baseline model, beautiful. Convolutional neural network, I think that is VGG mini or tiny VGG, looks like that. Compile the model, fit the model, then compare the loss curves. And then data augmentation if you really wanted to. That's amazing, my friend. You're going to be very excited by the upcoming sections as you keep going because you're going to get into transfer learning and you'll see how we'll blow all of our previous models out of the water. So we want TFDS load. Thank you for sharing that, Ashik. That is some phenomenal work there. We want CFAR 10. CFAR 10. And then source code. Well, where's TFDS load? There we go. Example load split equals train test. That's what we want. Shuffle files equals true. I'm trying to do this by just going off the documentation. With info equals true. And then as supervised equals true. I believe this is the same as what we've got here for notebook number 7. Yeah. Okay, this needs to be, that's a list. CFAR 10, shuffle files with info. Oh, we still have a P100. You can hear me right, Ashik. Factory reset runtime, yes. Gonna move this over here. TensorFlow playground. Tesla P4, that's what we want, baby. Get data. Shuffle files. This should be relatively quick. Okay. No mixed precision training. Hamzanator, what's going on, my friend? And thank you, Ashik. I appreciate it. No mixed precision training. So we're going to just do it as is. So build a model. Let's make a function. Create model. Mixed precision. Oh, do we want to do that? I got an idea. Mixed precision equals false. And then we want to... Did that work? It should have. So base model equals tf keras applications dot efficientnet b0 include top equals false. We're going to base model dot trainable equals false, and then download base model and freeze underlying layers. Base model, we've gone through this on a previous stream, but I want to just get really good at doing it. So then we need to create functional model. Inputs equals, we want layers. Import TensorFlow. From TensorFlow.keras import layers. Layers, there we go. Layers.input, input shape equals 224. I'm a little rusty with this code at the moment. Inputs, I haven't coded in a couple of days. I was making videos. X equals base model inputs. We need a global average pooling layer. X equals layers dense. Now we need something from here. DSinfo dot features, is that what it is? Wonderful. Features label class names. Is that going to give us class names? What attributes does this have? Classes? Names. Oh, of course it is. See, TensorFlow documentation doesn't tell you this. Names. Okay, so we have 10 classes of images. Beautiful. I'm going to put this under class names. Equals that. So we set some global variables. We should. Batch size equals 32. Input shape equals 224, 224, 3. TensorFlow. Katuro says TensorFlow or PyTorch. Hey, programming is lit. Renuga, right? Hasbanator says, what's the difference between YouTube videos about TensorFlow fundamentals and the Zero to Mastery TensorFlow course? So the YouTube videos are the first 14 hours of the course. And so here, I can just show you. The YouTube videos are these 3 sections. 0, 0, 1, 0, 2. The course is the rest of these sections. So like triple the amount of time as these sections. You can see that here. So before signing up to the full course, you can watch the first 14 hours of video on YouTube in a 2-part series. Part 1 contains notebooks 0, 0, 0, 0, 1, and some of 02. Part 2 starts off where Part 1 left off and finishes the rest of 02. So YouTube, these three, rest of the course, these 1, 2, 3, 4, 5, 6, 7, 8. Class names, beautiful. Dense equals, we want 10, and outputs equals going to be outputs. Here we go, we can set this. Output D type. No, we don't have to. We actually don't have to do this. Create model. Yeah. Outputs equals layers dot activation and then softmax. And then D type equals TF float 32. Name equals output softmax. Programming is lit. Do I play games? Yes, I do. Not very much. Renuga, it sounds like you've done more than enough projects to move on. So I'd try out classification and just, if you want to keep doing more projects, do more projects. If you want to try out classification, try that. Okay, let's finish this model function. And then return model. Is this going to work? Model equals create model, model dot summary. Input shape. I think this is where does this need to be a list? Hold on. Oh, is it shape? Name model is not defined. Huh? See, this is why I have a previously created notebook. I always get confused with this input layer. This is what docs are for. Shape equals input shape. Is there? Ah, I haven't created the model, have I? Did you catch that? This can be a tuple. I'm confusing myself here. That could be a tuple, and then we have model equals TF carers model. That's what I didn't create. Inputs, outputs. Here we go. And once again, see, I'm rusty at creating models. I haven't got the X here, and I haven't got the X here. Okay, now we're on. Fish on. Fish on. I'm good now. Float 32. Beautiful. Okay. Now, here's a beautiful thing where we can just go from TensorFlow import mixed precision, and then mixed precision get. I need to import it so I have the methods. Mixed precision. Give me your methods. Set. Come on, autocomplete. This is why Colab sometimes sucks for development. Because mixed precision, I mean, it doesn't tell you, it doesn't give you the methods of a certain... Oh, from TensorFlow.keras, that's why I don't have it. Mixed precision. Global policy, there we go. So float 32, that's what we want. No mixed precision training. Tick, tick. Now, compile model. Should I compile it before? Should we just compile it in here? In the function create model, compile model, model.compile. What do the labels look like? For image label in train data dot take one print image label. Our labels are label encoded. So let's do that. Loss equals, we need sparse categorical cross entropy. If your labels aren't one-hotted, optimizer can be tf keras optimizers dot atom, and metrics equals accuracy. Compiled model, beautiful. I don't want to compile the model there. I want to fit the model. History, no mixed precision equals model.fit. Will this work? Train data. You know what we haven't done? We haven't loaded our train data, but it might work anyway. Epochs equals 3. This is where we're going to run into some errors. Test data. No. Validation data equals test data. Validation steps equals len equals int. We'll just validate. So this is going to error. Yep, there we go. So we need to batchify our data, pre-process it. Because once you download data, what do you have to do? You have to pre-process it for a model. So we only really want the first 10. We actually only want 2. That'll do. So right now, oh, we don't even want 2. That looks a bit better. Now, we need to batch and pre-process data. So what is wrong with our image data at the moment? It's not normalized. So the values are between 0 and 255. And we also need to turn it into, it's uint8, so we need to turn it into float 32. So def. And our images are probably all the different shape. No, you know what? Our images are actually 32 by 32. This is CFAR 10. Because see here, 32, 32. Print image shape equals image dot shape. This needs to be an F string. What's chat saying? I I've used Linux and Ubuntu. I used both. Paperspace is great. I've used it before, but I mostly use Colab. You can trust Paperspace with your credit card, yes. I would trust them. Alex, what's going on? Shivans, what's going on, my friend? Oh, someone asked... Ashik, where did you answer that question? Okay, I'm just going to keep coding. I'll jump to the chat in a second, but I just got to get this set up. So we need to create a pre-processing function for this image, image tensors. So let's do that. Pre-process image. It'll take an image and a label tuple, and then it'll just return. We just need to cast the image to TF-float32 and the label. So I think that's all we need to do. Really short helper function, that way we can map to that. So we'll go pre-processed image equals pre-process image label, and then pre-processed image 0. Oh, pre-process image. And we also we don't need to normalize it because EfficientNet has a normalizer in it. Turns an input image tensor into float32 D type. We need our input data in float32. Wonderful. Now let's plot an image. Watch this. Code equals import matplotlib as plt, no, .pyplot as plt.imshow image plt.axis equals false. We'll run that. Wow. That's a very... I think that's a horse. What do you think? That's a horse. Let's get a title there. plt.title equals class names label. Horse. Okay, so our images are pretty crap quality, but that doesn't really matter. We're just figuring out how to batch and pre-process data. Let's batch and pre-process data. Prepare data loaders. So right now, train data needs to be train data. We want to map our pre-process image function. Image. And then we want to... What order do we want to go in? Map, shuffle, batch, prefetch. Map, shuffle, we'll shuffle 1,000 at a time. Batch can be 32. Batch size, prefetch. Now, prefetch, num, parallel. What's the... Because right now, train data is options data set. We want it in a prefetch data set. So we want here, num, parallel calls. Yes, this is what we want. Equals tf data dot autotune. num parallel calls equals TF data auto tune. Test data can be the same, except we're not going to shuffle it. Map preprocess image num parallel calls equals TF data auto tune. We could copy and paste this from other places where we've already written this, but where's the fun in that? Batch size and then prefetch num parallel calls equals. Oh, I don't actually think we need that, do we? TF data prefetch. What parameter does prefetch take? Buffer size. Yeah, why not? TF data dot auto tune. This basically says TensorFlow, figure this out for yourself. How do you load this faster? So now, if we go train data, test data, what does it look like? Num parallel calls, prefetch. It doesn't have that. It has buffer size. Buffer size. Buffer size. Beautiful. Okay. Now we're good. See, what we did there was before, when our model errored out, input 0 is incompatible with layer. So the expected shape equals that, but the found shape equals that. So our images are actually 32 by 32, but this wanted, because we set up our, see how I said, if you've done the course, a lot of the errors you'll run into in any sort of deep learning is the input shapes of your tensors. So what we just did was we adjusted, our input shape is not 224, 224, 3. It is actually 32, 32, 3. Image size of CFAR 10. All right. So I'm going to put that down here. That can be one of our global variables. Input shape. This is just some boilerplate code. Now see how this updates? Input shape, or the output shape is now this. And so that's what we want. This is going to be without mixed precision. So before this didn't work, but now it will. How fast do you think this will go? You've made it to the intermission already? That's some swift progress, my friend. And yeah, I had to put in the intermission there, otherwise everyone's going to be sitting down for 10 hours straight watching TensorFlow code. Oh, is this going to work? Okay, not too long per epoch. It's because our data loaders are pretty fast. The first epoch's going to take the longest. But now we want to... What difference am I trying to make here? Okay, so that runs pretty darn fast. Now, let's create mixed precision training. So I'm pretty confident now I can do this off by heart. Set mixed precision training to on. Requires a GPU with compute score 7.0 plus. I'm going to show you something really cool when we start making slides, but I thought I'd start this off by just writing some code. Okay, so that's taking about 21 seconds per epoch. We're not really pushing the accuracy above 50% on CFAR 10. That's okay. Mixed precision dot set global policy mixed float 16. Oh, do we have a Tesla P4? Oh, we don't have a Tesla T4. We have a Tesla P4. That's bullshit. We need a Tesla T4. Okay, we need to reset this whole thing. GPU runtime. No, we need a factory reset runtime. Factory reset runtime. Yes, GPU is available for me right now with Colab, and it is 1:50 p.m. But I'm pretty lucky, Renuga, because I live in Australia. Tesla P4. We need a T4. And not my time zone is kind of different to the rest of the world. Tesla T4, yes. Note, if you're using Colab, you'll need a Tesla T4 for mixed precision. Okay, now mixed precision will work. And we should see a fairly good speed up of epoch time here as well. Maybe I'll only do 3 epochs, just to save time. So that's about 21 seconds per epoch. Check D types of layers for layer in model 1 dot layers 1 dot layers print layer name, layer trainable, layer D type policy. Okie doke. Did that work? We downloaded some data. Yes, we did. Wonder if I can run this max. Then zoom in. Can you all see that? There we go. So that's what we wanted. We want our data sets in TF float 32. We'll run this. Do we have the correct layers that we need here? I'm actually going to put model 0 here, because model 0 can be no mixed precision. Model 1 can be mixed precision. Model's going to fail. So before we took about 21 seconds per epoch with a Tesla P4, but we've just set up to use a Tesla T4, which is a faster GPU. You're totally right, French Toast Mafia. It's Alex, right? Am I remembering that correctly? My brain gets confused when I see names in the chat and try to remember your actual name. Yeah, going over the fundamentals. Very, very wise move. Yeah, you can always use Kaggle notebooks as well. though the reason I chose Colab was just because it's the easiest to access. And easiest to share. You can share it from here. You can save a copy in GitHub. Ashik, you're totally correct. I forgot about ML Fit. 1 second. So what do we get? 3 epochs. ML Fit. I want to check to see if this works first. ML Fit. You do an epoch. 5 push-ups per epoch. We got 15 to bang out. Let's go. 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! 15 push-ups. I'm a little bit sore from jiu-jitsu over the past few days. Let's check the data types of our model. Model 1 is not defined. That is okay. We will now go create a new model. Model 1 equals create model. Model 1 dot summary. Beautiful. Mix float 16, that is what we want. Now, let's fit the same model as before. Could we functionize this? Yes, we could. But history with mixed precision. Fine tuning. How much faster is mixed precision? Yes, Renuga, I think about everything in terms of machine learning. Look at this. What a speed up we just saw. Oh no, that's because the data's already loaded for the first epoch, I'm guessing. Nope, we see a significant improvement from 20 seconds per epoch to 15 seconds per epoch. Now, if we turn on fine tuning, reset mixed precision, let's write some code to def check layer attributes. Layer for layer in layer. No, we want target layer. Target layer in target layer. Yeah, that'll do. Print layer name. We want layer trainable, layer dot dtype, layer dot dtype policy. Check layer attributes, and the target layer can be model 1 layers 1 layers 10. Beautiful, that's what we want. Okay, now reset mixed precision. So mixed precision, set global policy, float 32. And then global policy, float 32. Now, does this reset our layers? No, it doesn't. We need to go back to here model 0. Okay, this is back to float 32. Okay, I'll be back in a sec. We want to fine tune. Ashik asks, why do we multiply validation steps by 0.15 here? And so we only validate on 15% of the test data. So it's a little bit quicker. That's all. Now, for layer in model 0 dot layers 1 dot layers layer dot trainable equals true. We're turning all the layers to trainable. You know what? I forgot when creating model 0 was setting this training equals false. So I'm going to have to reset this. I'll just run that again. Yeah, you're completely right, Ashink. On the course, for a lot of the time, we validate on the whole set. But once we start using larger data sets, you want to save yourself time. Because you can always validate on the whole data set by going so that'll evaluate, this will evaluate on the whole test data set. We get roughly the same results. Okay, now we've set training equal to false, that's what we need. Fine tuning. Yes, I actually need to recreate model 1. Beautiful. So this shouldn't take too long. And then after this, I'm going to use some code. How can I do this? I want a photo of before and after mixed precision. It's not that hard to do, Daniel. You can do this. All right, beautiful. We've got what we need. Renuga says, what do you do with your deep learning PC? It is downstairs. I don't use it at the moment because I'm using Google Colab because I'm making course materials. I wanted to make sure I use the same materials as or the same tools as my students. However, I am going to be using a lot in my future project after the course is finished. Fight for it too, yeah. There we go, that's what we want. All trainable. Oh. That's maybe not what we want. Batch norm. Some of those should stay false. I thought we fixed that. Oh well, we'll see what happens. We'll come back to this if it doesn't work. So now we want to no, this is validation steps. See you, Renuga. Have a great day. Thank you for stopping by the stream. Ashik asks, how do you deal with imposter syndrome? I don't. I used to have it, but then I realized, why would I feel like an imposter when I'm just me? And plus, imposter syndrome, I think it's healthy to feel because it basically, imposter syndrome is you realizing that you could be better than what you currently are. And so I treat imposter syndrome as a signal for the potential for potentially improving your skill set on whatever it is. So I think it's pretty healthy to feel. In fact, if you didn't feel imposter syndrome, you'd probably be a maniac. And you say, how do you get good in data structures? In data structures, you just write lots of code and build things that you want to use. So like a dictionary in Python is a data structure. A list is a data structure. A tuple is a data structure. It just depends on what project you're working on. You'll only get, so once you start to work on more projects, you'll start to get familiar. Okay, maybe I should use a dictionary for this. Maybe I should use a list. Maybe I should use a database. Maybe I should look at, who knows, something. What did I get wrong here? Fine tune. Huh. This doesn't take very long. So I'm curious to see if fine tuning is actually set on here. Maybe because our data set isn't actually that big. Turn on mixed precision training. Dan, you've already checked this. I'm going to start making some slides in a second. Mix float 16. But yeah, imposter syndrome is just you, I'm repeating what I'm saying before, but it's worth it. Imposter syndrome is just you realizing that you could be a better version of yourself. Now we want to turn model 1 to fine tune. Wonderful. And model 1 dot for layers, for layer in model 1 dot layers, print layer name, layer trainable. False. Now we want to, for layer in model 1, layers 1 dot layers. And plus, imposter syndrome, it comes from when you're trying to be someone you're not. So a real quick cure for imposter syndrome is just be you. If you try to be like someone else, then you've got competition. I'm a big fan of the whole thing, just no competition whatsoever. I have no competition in life because I'm the best in the world at being me. So no matter what field you go into, what you decide to do, what you decide to create, do it with the mindset of having zero competition. Turn this to trainable. Wonderful. Now I think this should now be all trainable. False. I thought I just set that to true. Layer.trainable equals true. Okay, that's probably the better way to do it. Did I set mixed precision back on here? Yes, I have. Mixed precision. Does that make sense, what I'm saying about imposter syndrome? Of course, you need some skill to back that up when you have no competition. But too often people are their biggest critic. Not enough people are their own biggest fan. You need both. They balance each other out. Okay, for layer, I've confused myself here. Classic. That's what I want to do. Check layer attributes, model 1. After this, we're really got to start making some slides because I'm getting distracted by writing all this code. True, 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 true. Mix float 16. Holler at your boy. That's what we're after. Oh, that's going to error. Now, Ashik says, I know how to use a tool, for instance. Understanding the source code, I'll give you a little trick. I go into FastAI and TensorFlow source code and I don't understand it either. It's only once if you want to get familiar with it, you need to basically be rewriting it and re-going into it. I'm using TensorFlow as an API. So I know what my objective is to complete. Is my objective to rewrite TensorFlow? No. Is my objective to use TensorFlow to build the things that I would like to see exist in the world? Yes. So I'm not getting confused there with going, hold on, do I need to rewrite TensorFlow? If it comes to that point where I need to rewrite some TensorFlow code to suit me better, then I will go into TensorFlow and start reverse engineering stuff. However, I've been learning to code for 3.5, 4 years. Jeremy Howard, creator of FastAI, has been he'll say it himself. It's been coding for 30 years. So it's rewiring your brain to think in different paradigms. And the people who develop TensorFlow code are seasoned software engineers working for Google, maybe not working for Google, who knows, but that's where it started out as. This should be faster. See you, Renuga. Thank you for tuning in. Enjoy the classification section. Is it faster? Slightly. Okay, so mixed precision is slightly faster on this. Let's start making some slides. So I'm going to start writing some code in this little fun app that I found because it makes good code pictures. Because I'm going to start making some slides. Mixed precision training before and after. Okay, let's see if we can do this off by heart. Whoa, where'd that go? Appearance, GitHub, wonderful. Import TensorFlow as TF, import TensorFlow as from TensorFlow.keras. Import mixed precision. There we go. Does that actually look like Python? Doesn't matter. Now, how do we do this? We want no mixed precision first. No mixed precision. That's what we want, actually. I like this little app. Makes your code look beautiful. No mixed precision. Import TensorFlow as TF. Beautiful. From TensorFlow.keras import layers. So create a model. Create a model can be inputs equals layers.input. Will this code run? Is it input shape? It should be input shape. Input shape equals 224, 2243. X equals, oh, we actually need base model. Download base model. So this can be base model equals TF keras applications, double P. Applications dot efficient net. Why are we writing this here? Why don't we just copy and paste what we've already got? Mixed precision is faster there. We'll conclude with that. That way, we can just copy this. Boom. Come to here. Boom. This way we know it works. So I'm going to get rid of that. Now this can be outputs, and this can be activation equals softmax. Wonderful. And then we'll get rid of this line. Come back over here. There we go. Hold on. Why is that not looking the right color? So this is before mixed precision. should we do it this color? Oh. No, I like the GitHub theme. There we go. Okay. Create model. That will work. So I'm going to export. This can go to assets 00 model creation, no mixed precision. Actually, this is 07. And now let's add in mixed precision. Mixed precision requires output layer to have D type equals float 32. Now, mixed precision, we can separate the output layer here. Outputs equals layers activation softmax D type equals TF float 32 X. Beautiful. And we want to, from TensorFlow.carrots, import mixed precision, and then turn on mixed precision training. Mixed precision dot set global policy mixed float 16. So that's it. That's the only main difference. We can get mixed precision in 2 lines of code if we really wanted to. That and that. So let's save this one. What did we save the last one as? 07 model creation with. Okay, now we come to the keynote. Delete. So this is where some ease and delight comes into things. We create easy to understand diagrams. Easy to use diagrams. Bring in both of these. How's the chat going? Oh, Ashik, you're going to love what's coming up in the upcoming modules. Yeah, well, this is part of, if you look at my videos, this is why I made my videos to begin with at the start. If you go to my videos, you can see I didn't know any Python at all, or machine learning, or deep learning, or whatever. And now I'm writing this stuff off by heart. Let's make this 900. Look at this, ladies and gentlemen. That is some good looking diagrams. Before and after mixed precision. Does that not look cool? This is before, after. Mind blown. Okay. Now let's get a little label here. Copy that down here. Come down. Put this in the center. No mixed precision. with mixed precision. Done. There's a slide before and after mixed precision. If you can ever use a picture, use a picture. I wish you could copy that code, but we're going to see code in notebooks. Yeah, that's the way you do it. You find people who are better than you at things and you look up to them. And you just realize there's no secrets here. Like a lot of the coding world, you can find like people who, like techno people who are like, meh, 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 you have to be smart. How do you not know this? And it's like, if you can read, you can learn this stuff. So example transfer learning use case, we don't need that. Why use transfer learning? What we're going to cover, we do need that. What's another slide that we need to make? Let's make another slide together, hey? We're just ticking boxes. Boom, 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 boom. TK. Did I make? All right, let's make a table here. Food Vision Mini versus Food Vision Big. Dataset source, mixed precision, data loading. What did we use? Did we use prefetch? Dataset source. TensorFlow datasets. Target paper. Target results. This is 77.4%. Top 1 accuracy. Beat deep food paper. And this was, what was the food 101 data vision? You broke your fast? I think if you're young, you don't need to be fasting. So Sheik, if you're 20 years old, I don't think you need to be fasting very much. Beat Food 101 paper. Okay, that's what we're trying to do. Well, we've already, this is a spoiler alert, we actually do all of this. TensorFlow datasets, pre-processed, download from Kaggle. Train data is 750 images, is 7,500. What's 101 times 75? 7575. Data loading, performant TF data, API, performant, TensorFlow pre-built function. Okay, I think that is a good looking table. Does this look better if we bold it? Nah. This is what a lot of people don't think about. They don't think about how their things look. Sure, you've got great information, but how does your stuff look? Table, comparing difference between Food Vision Big, this notebook, versus Food Vision Mini, previous notebook. Oh, I don't want that. What happened here? I think that is good enough. Excellent. Where's another TK in here? Image of data loading with prefetch versus without prefetch. Oh, this is going to be a fun one. How do I describe this? I'm going to pull out my friend, hands-on machine learning with data loading. Where is it? Notion. Book. Have I got the Kindle version of this? TensorFlow data. 413. Oh, this is cool. The data API. Apply. I wonder if I've got this on Kindle so you can read it as well. I'm reading hands-on machine learning, by the way. Beautiful. Okay, do I have the Kindle version of this? And I don't have the Kindle app? Library. Search. I thought I had machine learning. Skip link. I might buy both if I don't have it. Why don't we do that? Hands-on machine learning. Kindle. $54. Nearly double the paperback cost. Stuff it. Oh, I need to go over here. Sign in to Amazon. Autofill. I just did. I just bought the book. I used it enough. Aurelian Garon deserves my cash. Here we go. We're downloading hands-on machine learning. A good book will change your life. I'm a big fan of buying books. Downloading. Okay, so we need image of loading data. I like to have digital and non-digital versions without prefetch. Okay, so what sort of keynote can we have for this? What is TensorFlow datasets? Okay, here's what we need. We need something visually explaining this. Batching and preparing datasets. So we have a dataset, then we map a function to it. What is this? Page 421. Something similar to this graphic. Fast AI book. After the TensorFlow course, I need to just focus on one thing. So I'm not reading much else at the moment apart from hands-on machine learning. Oh, I'm reading novels, of course, because I always read. But boom. Here we go. So, okay. Indexing is happening. Am I allowed to show this on stream? I think the book's open source anyway. Aurelian, I'm showing your book on stream. I've recommended it enough anyway. So if we go here, we want 420. How do I just go to page 420? I love how the page that I'm on is 420. This is what we want. The data API. Boom. Okay, is your... Wow, this is a big book. That's what we want, something like that. This is beautiful. It's just like the physical copy. There. So I'm going to copy something like this. Hide that. I'm going to replicate this in my own style. But I only want these functions. Just bring this over here. We'll get rid of that. And we'll get rid of that. So So this is what I want to recreate, something like this. So what I'm thinking is we just have I don't use repeat, so I don't need that. That's a very good way of demonstrating batches. Prefetch. Bloop. Data set comes out here. Okay. We'll cancel that. How can we do this with... Actually, you know what? To keep in the format of the slides, let's see what we can borrow from elsewhere. I like using pretty colors. So I'm going to use this. If I want TF datasets is going to come... If in doubt, try it out. So we want here, and this is going to format that, arrange, angle 0. This can be map. Map, it's going to auto-capitalize for some reason. Shuffle, and he's used a dice here. That's great. Shuffle. Oh. That's what I could do. Shuffle. Shuffle can be... What I might do is a little outline for each one. Yes. They originally started as a trifecta, but then we... Can I zoom out on this a little? I want to zoom out. Oh, I can't zoom out on the picture. I'm going to move this like that. Okay, I know what I'm going to make. No. Get rid of that. Okay, there we go. That's what we want. More space. So I want to replicate something like this. So I'm going to have... I actually want this to be blank. Blank. 3 squares. Like that. And then when map comes along, we want to start with some tensors. That's what we want. Where's one of my other keynotes with tensors? So, keynote. Number 3. Convolutional neural networks. Yes, yes, yes. I'm going to get this tensor. Tensor. Boom. Start with the tensor. And then, but this is actually going to be non-normalized. So let's change every value in here. 0. We'll make these up. 13, and this can be 25, 125, and also that can be ... and this can be 1, 14, 200, ... I read the whole book. Cover to cover. I think I skipped one chapter on SVMs. But I've read this whole book cover to cover. Have I done all the exercises? No. But a technical book is, even if you read it cover to cover, it doesn't matter. You're right, you need to practice the concepts. A technical book is a reference book. As you read it once, but then you keep going back to it to see what you should do. So that's what I'm doing now. I'm referencing back to it and practicing it. I've written lots of code. So although I'm looking at this picture and I'm trying to make my own picture, I have replicated that picture in code here and explained it, what it does. But this is the way you want to do things, is attack it from like 7 different angles. ... map. And then you do something here, you shuffle the order. Now, what's our tensor originally, what order could we originally put it in? Shuffle, and then we want to batch. So little blocks, so this is batch. And then this is prefetch. And then the output is another tensor. Wonderful. So this is a very simple diagram. I like this diagram. So map, I want some titles in here. So let me get some text. Map, shuffle, batch, and then prefetch. I'll do one for map as well. Map. Okay. So I think that's about all I need from this. I like that diagram. I just paid $50 to look at that one diagram. That's okay. I've now got the Kindle copy of Hands-On Machine Learning. So let's prettify this in some way. Dataset, your dataset, map, shuffle, batch, prefetch. Could use Whimsical for this flow through, couldn't I? Whimsical's another great tool that I use, but let's just keep it simple. We'll use straight up Keynote. So, map. That's what I could do. Map. And then outcome of map would be a tensor that is changed. Batch, prefetch. This is a good idea. These are now float 32. Wonderful. Push that over a little bit, push that over a little bit. That can go over there. That can go over there. And then prefetch comes over here. Okay, wonderful. So I need to, what's a good image for map? I could use an actual map. I'll just use the actual function. Great idea. Let's can this. Def, preprocess, image, label, tab, image label, return, tf cast, image, tf float 32, label. Boom. Well, maybe I'll just call this pre-process. But it can't be too wide. So image equals tf cast image tf float 32. Return image label. Is that as small as that can get? No, it's not. It needs to be tf float 32. That'll do. So 0 pre-process function. So then I want to assets. Boom. Look at that. Now, oh, that is what's up, man. Doesn't that look cool? Could be a bit bigger, but we'll just leave it at that for now. Map. And now we want to shuffle. So I think I can just make these different colors. Shuffle can be, style. And then this color can be this. Then we need to draw an arrow. We need it white, so it stands out in the background. And then Control C. And then that can go to the back. And then we're going to rotate a little. Does that look like shuffling? Because then we can have I actually don't think I need that. I'm going to put arrows between these in a second. Batch. Tensor 1. And the text we want on this is Airbnb serial, yes. Okay, that looks better. And now batch. We need to break our tensors up into batches. So Shivanj, you're completely correct. You just have to know where to find it. Renuga says, how much time did it take me to create the course? Great question. At least 6 months. But with a course, you have to do everything like 4 times. You have to learn it yourself. You have to make sure everything works. Then you have to make materials to teach it. And then you have to actually teach the materials. So there's 4 times. Learn, do, create materials, teach materials. 4 times. So it takes a long time to teach courses. So that's why after this course, I'm going back to, instead of doing more courses, I'm going back to working on my own projects. Batch. How can we make a batch image? One, two, three. 1, 2, 3. 1, 2, 3. 1, 2, 3. Batches. What color can these be? Oh no. Style. Color fill, yellow. Batch. And now prefetch. I have a perfect idea for this. So many different items here. Now, I need a little drawing. This is what happens with prefetching. This is no fill. Border. We want line, we want dashes, and we want I need a green color here, don't I? So prefetching means these tensors are being prepared while these tensors are being computed on. Okay, that's a good idea. So get rid of this. Arrange 0. Being prepared, being computed on. Does that make sense? Now let's go back to here. Yes, there we go. So this is an even better diagram. I might actually use this. I'm pretty sure, what's the licensing of this book? I'm pretty sure I could just use this. As long as I reference it. Roadmap. Code examples. Using code examples. Answering a question by citing this book and quoting example code does not require permission. Incorporating a significant amount of example code from this book into your product's documentation does require permission. So I'm guessing I can use the image as long as I reference it. But I was going to reference it anyway. So this is the entire point about prefetching. So without prefetching, your CPU has to prepare 1, use 1, prepare 2, use 2, etc., etc. With prefetching, you prepare 1, use 1, prepare 2, use 2, prepare 3. I'm going to replicate this a little bit. But I'm also going to save this. Prefetching. And then I'll reference this. Yeah, Ashik, you're right. Mini courses. What would you classify as a mini course, Ashik? Yeah, you're right. Alex, French Toast Mafia. I'm hoping your name is Alex. I find if I teach something, I understand it way more because I have to understand it like 3 times. I have to first understand it for me, then I have to implement it myself, and then So there's one form of understanding is reading and just knowing the name of things. Another form is being able to actually do it. And then the final form is being able to explain it in a way that someone else can understand. That's why I don't like using direct diagrams copied from someone, even though I could definitely do it. I like to replicate the diagram myself. Assets. '07 prefetching from hands-on ML. TK quote source, etc. Renuga says yeah, so I could make like 4-hour mini courses or something like that. Just get real specific. Like if you want to build this in whatever, here's how you do it. So Renuga's asking, what, for a beginner, what should you use for gradient? Why don't you start, you can start with the free. You don't have to pay anything. I'd start with the free. And then if you need developer for ML, AI engineers, data science and researchers, you can go to that. Mid-tier instance. So you get low instance types and mid instance types. Instance types. M400 GPU. Instance types. Yeah, you get a 8 gig GPU. So yeah, or just use Colab, or Gradient now includes a free GPU plan. My advice is always go free until you know you need to upgrade. Okay, back to the keynote. I think this could use some consistency. So I'm going to change this to blue, which is the same as that. Is it? It is. Batch. Because this can be all, hold on, ungroup. Yes, this is beautiful. Move these across here. Now they can be yellow. This is what we should make it, at least 3 tensors. Oh, no, 3 will be good. Now that is some diagrammage. And then, once I've done that, I can go into this. Yes. So this is our pre-processing pipeline. Dataset, map. Then we get this from our map. And then shuffle. Then we batch our tensors. And then we prefetch. And this is on the CPU. I'm going to make that CPU and GPU. What size text are these? These can go down to 30. I have a rule, minimum 30 size text font when making boom. That's what's up, my friends. How we looking? How we looking? If you want an insight into how I make slides, this is how we do it. Siobhan's good timing. Living the dream, writing and coding. Yes, I'm very lucky. Regression. So you don't usually use accuracy for regression. Siobhan's. I feel honored that you listened to me on the commute home. Maybe this is too big. Can we just make these a little bit smaller? So maybe 175. Hey, that looks better. And then that's what we want. We want it so you can see the tensor. Who picked up that I spelled tensor wrong? There we go. We need to move this a little bit across so that it's all looking hunky-dory. Ho-ho, ladies and gentlemen. That's some prime looking diagram to me. Yes. Oh, I love it. Before we started off with just headings. Data. Does that make sense, what we're doing? And then the other side of this is that we see it done in code. Because that's what we want. We can see this being done in code right here. Oh, this is the dream. The absolute dream. Train data pipeline. This is what I prefer. We teach code first. I want you to see it being done, and then if you want to learn the theory, you can look up that shit yourself. Boom. Oh, need to get all of them. That'll do for now. All right. So if you start with the data, you pre-process. Boom, map function equals pre-process. You can parallelize that stuff by using TF data auto-tune. And then this is what you get out of that. And then you shuffle it, and then you batch it. And then because of prefetch, some tensors are being prepared while some are being computed on. That is primo. And then, if you want the technical explanation, you have a look at this. So where did I source this from? Let's open up another Keynote. I believe I've quoted hands-on ML before. There we go. Nope, not there. Source. Oh no, it was in section 02, wasn't it? 02. This is a big motherfucking course. Source. There we go. Aurelion, I'm quoting your image because I'm not recreating that. I think you've done a great job, and if I tried to recreate it, it would just be, it's already simple enough. This is source page. Hopefully it's 420 because that'd be great mean. No, it is 422. 422. Prefetching. Make this as big as possible. Boom. This is why you should prefetch. Take advantage of multi-threading. Move that down a bit. Doesn't that look beautiful? Now this could use a little bit of cleaning up, couldn't it? That's what it looks like in code. Move this down. This should really be a little bit bigger. Is that because these tensors are probably too big? Maybe I'll dull these down. Oh, they're already 30 point. Nothing lower than 30 point font, that's the rule. Spacing. What if I turn the settings down and bring the numbers a little bit closer? Hey. There we go. You got to get obsessed with how things look. Too many times you find stuff and it just feels like no one's given a shit about what they're making. This, you can now see how much care I take with these slides. And it's going to be the same with whatever project I work on. I actually need to delete that because there's only four there. Little details count, you know. Okay, now all of these need to be lined up. Prefetch needs to come down a little bit. Yeah, that's not too bad. There needs to be some space here, but maybe I'll bring this in. There. And now batch. Batch can come over a little. And now we center the whole lot. Victory. Absolute victory. All right, so you can code, but can you explain your shit visually? Now we'll get some little arrows. I believe I've already got some arrows. So we'll just copy this arrow. Wonderful. Can we squeeze a little arrow in here or not? Does that look like too much? I think that's a little bit cluttered. Get rid of that. Maybe we want one here. I think that'll do. Wonderful. Now, what other slide do we have to make? Image of loading data. I think I'm going to use Wonder, how do I contact Aurelion Caron? I'll just use the image. And quote him. Should we make this slide? How long has this stream been going for? Just over 2 hours? TensorFlow and sklearn have a lot of similar features, but also have a lot of different features. You can probably, I don't want to say everything you can do with sklearn you can do with TensorFlow, but you can probably do majority of it. However, sklearn has a lot of pre-built methods, so whether TensorFlow, you might find yourself writing a lot of TensorFlow code to replicate what you're doing in sklearn. If you want GPU computing, you'll want to use TensorFlow. Yeah, the main feature, TensorFlow's main feature is like you get NumPy arrays, but they work on GPUs and TPUs. Or actually, that's TensorFlow has many more features than that, but that's one of the biggest features. TensorFlow datasets. Let's make a slide for this. Oh, I want my code shots to look like that. No, you know what? I've got a better idea. Let's grab our... Bring our notebook over here. Get rid of some extra papers. We don't need that. Codi. We want... Oh, where'd my code go? There. Look at this. Always use a picture where a picture can be used. Do I need a table here? This is what I could do. I just replicate what's on the slide, what's in Colab, here. Boom, assets, loading TensorFlow datasets. Oh, this is the dream. Okay, and now I'm just going to grab this. Oh, that's no good. I want to change this to my favorite Airbnb font. Style. Why does this have a background? I don't want my text with a background. Fill. No. I'll just copy this out. That way, if I copy it out, TensorFlow datasets is a place for palace, not a palace, a place for prepared and ready to use machine learning datasets. Going to change this color. There we go. Siobhan's, it's on pause. Everything's on pause. Oh, sure? Sorry. Siobhan's asked, how's the novel going? It's complete. I need to just finish up probably 1 or 2 more drafts. However, it's been on pause for the last couple months while I've been doing the course. I figured out I need a strict one major project at a time. So as soon as I finish the course, I'm going to finish that and then work on a machine learning project. I need a Tesla T4. I've got a perfect idea. Is this locked? Can I export this as... Is this going to work? Haha, that looks cool. There we go. Boom. Oh, this is different size text. That doesn't look very good, does it? I use 42 text size for a lot of things too. And this should be at least a little bit bigger. There we go. We are getting somewhere, team. We are absolutely getting somewhere. Now, NVIDIA apparently are releasing a new GPU, 3080 Ti. Mid-April, hey? I usually find that when you're beginning out at something, you need to do like everything. But then when you're getting a certain level of skill at something, you need to like cut everything out and just get obsessed with one thing. 3080 Ti. Limit crypto mining. $10,240 CUDA cores. Holy crap. Okay, where are we up to? Done that. We need fine tuning before and after. Boom, keep it simple. Could I make a table for this? Where's our other TK? There we go. Yeah, chic. Learning anything worthwhile takes time. So I think I have a post on this. Probably. I write about a lot of shit. Did I have it here? Here we go. There. 1 year in, the honeymoon phase, also known as the noob gains period. You're much better than a beginner, perhaps even a little too confident, though this isn't a bad thing. 2 years in, the oh, maybe I'm not as good as I thought phase. Your beginner skills are starting to mature by now and you realize getting better is going to take some effort. 3 years in, the wow, there's so much more to learn phase. Not a beginner anymore, but now you know enough to realize how much you don't know. I'm here. So, this is what happens. Can you see this? Yes, you can. Knowledge. Outstanding initial results, noob gains, because you're learning everything. You're just absorbing it. But then you get to a stage you start to level out. And you're like, do I even know anything? But then you keep going and you get unexpected progress because you're like, you know what? I'm just going to go back in terms of my mindset. I'm going to approach it how I did at the start. I'm going to learn what I need to learn when I learn it. And then it goes up like this. So go read this post. I've been learning it for 3 years and I still forget to think of things like this. But yeah, 1 year in, great results. It's 2 years in, you're like, oh, maybe I don't know that much. 3 years in, holy shit, I've still got a lot to learn. And that's where I'm at. We'll just pass that now because I wrote this article about 6 months ago. Let's get into here. But learning anything worthwhile takes time. Prefetch. That's why I started making all this stuff online. Look at that speed up. No, I don't like that. this needs to be size 30 at least, doesn't it? Nah, 42. And that can't be bold. Food vision needs big, and food vision big comes with a TN. Okay, that looks good. Maybe we could add a column here. Much better. All right, now we just replicate the same thing here. Oh, I'll get this on the slide. Yeah, that's why I do these streams and make these videos, because we're all learning this stuff together. As much as I am a teacher, I am a student. It's a perpetual learning journey. People like to think you get 10 years of education and then you just stop learning. They forget that education is a noun and learning is a verb. You don't stop learning. What did I say the time was? Oh, this is looking beautiful. What other TKs do we have in here? I believe this might be it. This is wonderful. Get rid of all the crap in my bin. Okay. What other keynote did I say I wanted? Kinds of transfer learning. I don't think I need that. We don't actually use data augmentation in this one. Softmax activation with D-type. That's for mixed precision. Ho ho, Speedy Gonzalez here with these. What are callbacks? I need to fix this. Because this is a milestone project. So this one is actually different to previous modules. I'm going to cover some parts, and then I'm going to hand it over to the student who's going to cover their own parts. Why use transfer learning? TK. Okay. Add food vision big. Oh, Ashik, where is that paper? Revisiting ResNet. New ResNet, hey? Oh, 5 days ago. You legend. Oh my God. we find, perhaps surprisingly, we find that trailing and scaling strategies may matter more than architectural changes. And further, that's what we found out before. Resulting ResNets match recent state-of-the-art results. We show that the best performing scaling strategy depends on training regime and offer two new scaling strategies. One, scale model depth in regimes where overfitting can occur. Width scaling is preferred otherwise. So scale your model depth, so how deep it is when overfitting can occur. Increase image resolution more slowly than previously recommended. Using improved training and scaling strategies, we design a family of ResNet architectures, ResNet RS, which are 1.7 to 2 times X faster than efficient nets on TPUs. Oh, it's TPUs. What about GPUs? In a large-scale semi-supervised learning setup, ResNet RS achieves 86.2 top 1 ImageNet accuracy while being 4.7x faster than EfficientNet noisy student. Holy crap. We recommend practitioners use these simple revised ResNets as baseline for future research. Boom, Ashik, my boy. Great find, my friend. I'm going to save this to my ML reading. And 2.1 to 3.3x on GPUs. Oh, it's on TensorFlow already? Stay tuned. It's in beta. Oh, well, the GitHub links don't work. That's all right. This is beautiful. Oh, they use cosine learning rate schedule instead of an exponential decay. Rand augment. We use the momentum optimizer instead of RMS prop for simplicity. Table 10. Rand augment. Is rand augment in TensorFlow? Yeah. rand augment. This is great. I love learning about all of this new stuff. Read about this later. Oh, I don't want ML. Table 10. SGD with momentum. This is beautiful. Where is the hyperparameter settings? Table 8. What do they set momentum to? Who knows what this symbol is called? Yeah, Yannick Kilcher is great. Gamma. Okay. So set a momentum with, where's TensorFlow SGD? Momentum, maybe 0.9. Where were we? This is amazing. ResNets are back, baby. This is a great find, Sheik. Oh, transfer learning. Okay. I'm going to go and read this off stream, but I think this has been a good session. Have you all had fun? Thank you, Ashik. I've got some reading for this. Reading to do. ResNets are back, baby. This is probably going to be in Machine Learning Monthly. Need to get rid of all this. Or, could we run an experiment before we go? Oh no, I need to go and get dinner ready. Okay. I'm going to finish these slides off tomorrow and then get into recording videos. But thank you so much for everyone who's joined into the stream. Have we done what we said we were going to do? Create slides for 07? Yes. Make a little playground with TensorFlow code and other shears to practice writing code? Yes. Make notebook 07 ready for recording slide making. We've still got to add images where TKs are. You know what? Here's what we're going to do. We're going to try SGD with momentum in here. Let's do it, team. Who wants to try out some? So they reckon SGD with momentum works better than any other app optimizer. Let's try SGD with momentum. TF Keras optimizers. SGD. Who's ready, team? See, we read papers. Oh, mixed precision is not going to work. We read papers and we try to run. That could be a future stream series. Is implementing papers. Just live. Probably take me like all day. There we go. We got to test the T4. Let's try out their SGD with momentum theory. Plus, you know what? I want to also start learning PyTorch, so that could be a way to learn PyTorch, is we implement papers with PyTorch. Shit. Get the data. Yeah, I'm the same as you, Alex. I watch videos. I like to hear things visual or see things visually and hear things audibly, and then do it myself. And then reading is kind of the final nail in the coffin. Because sometimes I'll read a paper and I won't understand a fucking gram of it, but then I'll code it out myself and see the tenses and see the different things visually, and then I'll start to understand it. Is SGD going to work? Beautiful. How does SGD with momentum go against? What happened here? Did I not? So, Renuga, I get a lot of my papers from Twitter, as well as Archive Sanity. There's a lot of new papers from there. And also also things like Google AI blog. Google AI blog, just like all the big, if you find a company, go to their blog, and that's typically how I find their stuff. But otherwise, Twitter is great because you just other people find papers, and then I kind of find the papers that other people find. I mean, there's definitely too much out there that you'll find to figure out. Okay, so SGD with momentum gets basically the same results as Atom in about the same amount of time. We can work on that later. Papers with code as well. There's so many different places. You don't have Twitter? Well, that's okay. That's probably a good thing. You don't necessarily need Twitter. You can find everything you need to find without Twitter. All right, so that's going to be the end of the stream. We worked on making some slides. You saw a little insight into what goes into making different slides. We also did a few experiments in TensorFlow code. Tomorrow I'm probably going to finish off these slides and finish off the notebook code, and then start recording videos for section 7 next week. And then this part will be done. And then the next set of streams will be on NLP. So that's going to be really exciting. So thank you all so much for tuning in. I really, really appreciate it. I will see you in the next stream. As always, keep machine learning, keep moving, keep creating, and tell someone you love that you love them. Because I love you all.